A silent field of stars drifts across the void. A stable grid of ancient light. A frozen canvas that should never shift without reason. Yet one object breaks that stillness. 3I Atlas. A visitor that should obey every known law of motion, yet refuses to. Its path glides through the deep dark with impossible precision, holding a line that no natural object should ever hold. A line that grows more concerning the longer it is observed. Because, according to the European Space Agency, no force is acting on it. None. Their vector logs show zero pressure along its surface, zero gravitational distortion across its route, and zero magnetic influence that could guide its motion. A perfect absence of everything that should move it. And yet it moves. This is the opening wound in the data, the first fracture that refuses to close. A paradox born not from speculation, but from measurement, and from the careful hands of agencies built on caution. Motion without an identifiable input, travel without push or pull, displacement without cause. In the cold discipline of physics, this should never happen. In the silence of interstellar space, it is happening anyway. 3I Atlas continues forward, holding a velocity that should have decayed, holding a direction that should have drifted, holding a behavior that should have collapsed under the weight of chaos. Numbers should vary. Sensors should pick up noise. Trajectory should carry the fingerprints of forces as they ripple through the void. Instead, the data is clean. Perfectly clean. Too clean. As if the universe itself is removing the clutter. As if something is smoothing the numbers into obedience. And in that smoothness lies the darkness. A quiet darkness. Not of menace, but of precision. An object that moves where nothing should make it move. Inside a universe that insists every journey must have a reason. A clockwork cosmos now showing a gear with no visible teeth. A single anomaly drifting through the deep, hinting at a truth that hides behind silence. A truth that grows more unsettling with every kilometer 3I Atlas travels. Cold archives inside the European Space Agency preserve the moment 3I Atlas first appeared. A faint streak on a sensor frame. A thin intrusion against the black that should have been nothing more than noise. It was discovered during a routine sweep, a scheduled survey meant to catalog minor bodies that drift near the orbit of Earth. A task defined by patience, discipline, and long hours spent interpreting dim shapes across deep space exposures. The analysts expected another fragment of rock, another inert traveler crossing the gravitational lanes of the inner system. They did not expect motion with no recorded driver. At first, the data looked incomplete, as if the instruments had missed a force, as if a solar pressure gust had been overlooked, or a gravity well had been miscalculated. The European Space Agency scientists repeated the capture. The line remained impossible. 3I Atlas glided with a constancy that rang hollow, an almost deliberate steadiness that felt out of place inside the natural turbulence of the solar system. It came from a direction that offered no clues. A region of sky with no dense fields of debris, no known reservoirs of interstellar fragments, no typical signatures of wandering bodies that fall toward the sun. A motion without origin. The first confirmed logs showed a silent object entering observational range with a velocity that matched no known profile, neither cometary nor asteroidal, neither pushed nor pulled. Researchers moved through the early data frame by frame, expecting an error, seeking the touch of a force that had simply hidden in the numbers. Every calculation came back empty. Zero measurable radiation pressure, zero magnetic coupling, zero gravitational irregularity. 3I Atlas was moving as if the vacuum itself had opened a channel for it, a path through which it sailed without resistance, without interaction, without explanation. Its discovery spread quietly through scientific circles, carried in measured updates and cautious reports, always framed by careful language, always wrapped in the cold discipline of agencies that do not speculate. It mattered because motion must have a cause. It mattered because a universe that allows motion with no cause is a universe rewriting its own laws. It mattered because 3I Atlas did not drift like a fragment. It traveled like an object with intent. In the early days after detection, mission planners debated whether the trajectory could be modeled, whether a long-term prediction could anchor its position months ahead. Standard models broke down. Small uncertainties grew into sharp anomalies that refused to converge, as if the object resisted conventional mapping. A path that should have been stable, instead became a warning. Yet through all the confusion, the motion remained steady. 3I Atlas held its line with unnerving purity. A purity that removed doubt. A purity that confirmed one fact: something was guiding it, or something was missing from the equations, and that absence was becoming harder to ignore. 3I Atlas cuts through the vacuum with a motion that should be ordinary, yet every detail becomes stranger the closer scientists look. To understand its behavior, imagine the solar system as a vast and restless ocean, a sea shaped by gravity, radiation, magnetic fields, and the constant push of charged particles. Every object in this ocean drifts, tumbles, or bends its path in response to the forces around it. Nothing moves untouched. Nothing travels clean, but 3I Atlas does. Its trajectory remains sharp, quiet, and unnaturally free of disturbance. When analysts apply classical mechanics, they expect to see subtle curvature in its arc, a gentle pull toward the sun, or a faint nudge from the solar wind. The data shows none. The European Space Agency ran pressure models across the object's projected surface area, calculating whether photons from the sun could impart even the slightest drift. The readings came back with zeros so consistent they triggered secondary reviews. On magnetic tests, the object behaved like a void, offering no field interaction, no torque, no measurable coupling to the heliospheric environment. Gravity maps showed the same absence. 3I Atlas moved as if gravity touched everything around it except the object itself. Inside Mission Control, analysts layered vector logs across each other, expecting drift through time, expecting the normal noisy wobble that comes from formal uncertainties, from covariates spreading outward as the days pass. Instead, the curves overlapped in perfect alignment. The line did not widen. The uncertainty did not grow. It remained narrow, almost artificially so, as if the object refused to acknowledge the chaotic fingerprints of physics. That is where the darkness settles in, not in speculation, but in precision. Because perfect motion is not natural. Perfect stability is not random. Even the most rigid bodies experience microforces, hidden influences that accumulate and alter their paths. But 3I Atlas demonstrates a form of travel that appears sealed off from those influences, a motion locked inside its own private rules. When visualized in phase space, its behavior forms a slender thread, unnervingly clean, almost surgical, a path that remains linear where every comparable object forms a cloud of drifting possibilities. Analysts noticed that corrections which should have improved the model made it worse. Assumptions that should have clarified the trajectory only deepened the contradictions. And each time they removed a presumed force from the equations, the model aligned more closely with reality, as if the object's motion improved when science removed explanations rather than added them. This inversion is subtle, cold, and deeply unsettling, because science is accustomed to discovering hidden forces, not erasing them. The longer the European Space Agency observed it, the more 3I Atlas behaved like a phenomenon insulated from cause, as though its travel existed in a protected lane of physics, one that resisted interaction with the rest of the solar system. Yet, it kept moving, not accelerating, not decelerating, just moving, untouched by the very fabric meant to act upon it. Imagine looking at a compass that never wavers. Imagine watching a pendulum that never slows. Imagine measuring a trajectory that never drifts. In the quiet corridors of analysis labs, that is the image 3I Atlas leaves behind. A silent traveler gliding through a universe that insists motion requires force, while offering no force at all. A contradiction wrapped in data, a paradox carried forward with every kilometer it crosses. And somewhere inside that paradox lies the key to understanding what 3I Atlas truly is. 3I Atlas carries a list of strange facts that deepens the paradox rather than resolving it. The first comes from its surface signature. Spectral scans return a reflection profile that is almost painfully uniform, a flatness that does not match metal, ice, rock, or dust. A surface that absorbs and reflects in ratios too stable for any known composition. Uniformity of this kind is rare in nature. Uniformity is a warning. The second strange fact lies in its thermal behavior. Objects in space absorb sunlight and re-radiate heat, creating a measurable pattern that shifts as they rotate. 3I Atlas shows no thermal drift, no rotation signature, no cycling of warm and cold regions. Its temperature holds in a narrow band that does not fluctuate. Analysts describe it as thermally muted, a body that resists the natural breathing of heat that every object experiences in the vacuum. Then comes the paradox inside the vector logs. When the European Space Agency plotted the object's trajectory across multiple observation windows, they expected to see scatter, a widening cloud of possible future positions. Instead, the paths converged. Uncertainties collapsed inward. The data grew sharper with time, as if the object wanted to be found, as if its behavior preferred clarity over chaos. Researchers examined the possibility of hidden jets, microvents, or expelled material that might produce thrust too small for first-generation instruments to detect. But deep scans revealed no dust trail, no gas signature, no particulate emissions. Nothing that would explain propulsion. Motion without thrust. Direction without torque. Progress without pressure. The contradictions grow heavier. A fourth anomaly emerges when comparing 3I Atlas to historical catalogs. Every known interstellar visitor shows some irregularity, some sign of interaction with the solar environment. 2I Borisov carried a classic coma. ʻOumuamua showed a non-gravitational push you could measure, even if you could not explain it. But 3I Atlas shows none. It behaves like an observer rather than a participant, a traveler untouched by the medium it crosses. Another detail unsettles mission analysts. When plotted against background stars, the object maintains a constant optical profile, the same brightness ratio at every angle, a feat impossible for rotating bodies. Natural objects reveal themselves through changing geometry. 3I Atlas reveals nothing, and that nothing becomes a final anomaly. On two separate nights, independent stations measured a micro-shift in its apparent position, a shift so tiny it sat at the edge of instrumental noise. Yet the shift matched across both stations, a synchronized anomaly, too small to be atmospheric, too clean to be random. A coincidence that feels intentional. Each of these facts stands alone as a curiosity. Together, they form a boundary, a frontier where known physics narrows into silence. A silence that grows colder with every unanswered question. The future of 3I Atlas forces the scientific community to confront a question that grows harder to ignore. What does motion without force imply for the rest of physics? If an object can travel through the solar system while ignoring gravity, sunlight, magnetic fields, and pressure, then the rules that guide every planet, moon, and fragment may not be complete. The European Space Agency has already begun designing longer baseline tracking campaigns, extending observation arcs to capture even finer deviations in its path. They hope that at great distances, subtle interactions may finally appear. They hope the silence will break. But so far, the silence holds. A few analysts have suggested shifting to deep space mapping, a method that looks not at where the object is, but where it prefers to be, treating motion as a pattern rather than a product of force. If 3I Atlas continues to show perfect linearity, this could become the first confirmed case of inertial behavior that does not anchor itself to known reference frames. That would push physics into a territory it has resisted for centuries. The territory where cause and effect begin to separate. Future missions may attempt flyby observations, though planners remain cautious. Approaching a body that does not behave under normal forces carries risk. If its motion is governed by a principle that repels interaction, probes may struggle to maintain course. If its trajectory is guided by conditions humankind does not yet understand, instruments may fail to interpret what they see. And if no force acts upon it, then any encounter must be designed around that absence, using navigation methods built for an object that refuses to push back. Some researchers argue that the true value of 3I Atlas is not the object itself, but the framework it may force modern science to build. A framework capable of describing motion that emerges from state rather than influence. A framework where the universe contains channels, regions, or conditions that permit travel without exchange. A framework where silence is not emptiness, but structure. If such a structure exists, It may reshape how humanity imagines propulsion, exploration, and the limits of travel. Not faster, not stronger, but freer. Motion that does not rely on fuel. Courses that do not decay. Journeys that do not fight the environment, but bypass it entirely. 3i Atlas may be the first visible hint of such a principle, drifting alone through a system that cannot explain it. In the decades ahead, scientists will follow its path long after it leaves the neighborhood of Earth. They will measure every kilometer it crosses, every angle it holds, every refusal to behave. Because sometimes the most important discoveries do not arrive with noise or spectacle. Sometimes they reveal themselves through quiet precision, through the darkness between forces, through the cold logic of an object that moves where nothing should move it. As 3i Atlas continues its silent flight, it leaves behind a question that grows heavier with every observation. What if the universe has rules we have not yet learned to see? And what if those rules have been moving past us all along?